Okay, Bismillah ar-Rahman ar-Rahim. This is a tutorial. Basically what I'm going to do, I'm just going to go over the solution to the main problems, not the multiple choice questions, because the multiple choice questions, I think everybody got them. So let me just first of all go to this and get a nice pen. Okay, so now I will post these both the PowerPoint and the video. And where's my pen? Now, just very quickly, for the first question, the solution is here. But the one important point here is that I have a line here that is negative, right? It has a lambda 2 or negative, and this lambda 1 is positive. That means when I come here at this point here, for this lambda, the negative 1, the electric field will be this way, and using symmetry, it will be this way. So that means what? That means, remember I have a positive test charge here, the Q naught, the test charge is positive. So that means what? That means the y components both will cancel, and the x components will add. All right. Similarly for this one here, the positive one, this is positive. So that means I will have an electric field that is this way, and another, using symmetry, I have another electric field this way, and again it will have an x component and a y component, a y component and an x component, and these y components will cancel. So that means, that's why here I have E that is equal to E1x minus E2x, and the E2x, this one, which is negative, and the E1x, which is that one, positive. Now, please don't forget the I hat here. Most of you forget the direction, with the exception of 3 or 4, and also some of you forgot to mention the units. So this is the key here, and as the problem said, is that said E was given as to be 2K. Is it 2K or 1K? I forgot whether it's 2K or 1K. Let me just check. It's 2K, so that means we're missing a 2 here, right? So that means we're missing a 2 right here. So E is equal to 2K, and then lambda 1 over x. And of course, you have the I hat. Whether it's this way, it will be I hat. If it is this way, it's minus I hat. This is I hat, and this is minus I hat. And that's the solution for you there. Now, for the second one, the electric field at this point, for question number 2, the electric field at this point, and this is from the notes, that the electric field, as we saw here, is that it's equal to that. From here, I can find Q is equal to, just simply cross multiply, that R square E divided by K. K is given. R is right here. That's my R. That's the radius, which is 0.08. And of course, because it's square, so that means square over here. And E is the one that we need to know. He told me that each of these squares is equal to 6.5 times 10 to the power of 7, and that's why I have to multiply by 5 here. 1, 2, 3, 4, 5. So that means my electric field is equal to 5 times 6.5 times 10 to the power of 7. And please don't forget the unit here is Coulomb. Okay, so that's the first 2 questions. Let me forget to blow this up. So these are the first 2 questions. Second question, which is question number 6, we need to use Gauss's law, and this is a sphere. So if it is a sphere, then my Gauss's law in general, regardless of what the radius is, we said that for a sphere, E will always be like that anywhere. E will be like that, and N hat, it will be like that, right? N hat will be like that. So that means theta is always equal to 0, and cosine theta is equal to 1. So when I apply my Gauss's law, just like what I have here, my Gauss's law will be E dA cosine 0 is equal to Q enclosed divided by epsilon naught. Okay, and from here, that's why I have this equation here, right, where I have E is equal to Q enclosed over epsilon naught, and then I have the area, which is 4 pi r, the surface area, r squared. Okay, so that means, and of course r hat, because it's direction. So that means my electric field for any part A, B, C, D, E, F, all of them, the electric field is equal to Q enclosed divided by epsilon, of course not, 4 pi epsilon, and then I have 1 over r squared. Now, in order to find the electric field, I have to examine this Q. That's the only thing that I don't have, Q enclosed. For part A, Q enclosed is equal to 0, so that means E is equal to 0. For part B, A over 2, so that means you're here somewhere. That's where you are here at this point here. That means what? Again, Q enclosed is equal to 0 and E is equal to 0. Even at this point here, right, at this point here, Q enclosed is equal to 0 and E is equal to 0. Okay, now for part D, where I am somewhere here, right, 1.5, that's where my Gaussian surface, right, that's where my Gaussian surface is, then that means that my Q enclosed, please notice that Q enclosed is not equal to 0, and it's equal to this part here. So that means when I come in here, I say for part D, E, and F, for all these 3 parts, E is equal to Q, of course, 1 over 4 pi epsilon naught, and then Q enclosed will be rho times 4/3 pi r cubed. That's that's rho times V, because this is Q enclosed is equal to rho times V enclosed divided by r squared. If you cancel, these guys will cancel with each other, and 2 of these will cancel with, and then I have my general formula for E. The general formula for E for parts D, E, and F, it will be rho divided by 3 epsilon naught, and then I have R, because these 2 of these will cancel with 2 of these. All right. Okay, so that's this equation right here, right here. Okay, and then I can substitute for 1.5a for part D, and then for part B, R is equal to B. I can substitute for simply B. This will become B, and for part, so that's my part F, and then for sorry, for part E, and for part F is in the next question here, which is equal to 3b, right? 3b. Okay, so that's all you need to do in here. Sorry, this will be b squared, and this will be, sorry, 3b cubed. So that means, no, this is not 9. Okay, because I have to cancel these 2 with these. Okay, and then I will be left with 3. So it will be 3b. So this will be rho over 3 epsilon, and then you have 3b r hat. This is not right. Okay, and that's it. Okay, now for the last question, you have a conducting sheet. Remember, a conducting sheet. For a conducting sheet, this is the electric field. If it was an insulating sheet, I will have, for E insulating sheet, I will have sigma over 2 epsilon. And I showed you that in class. So now he wants the electric field right here. Because this is positive, the electric field will be directed this way. Remember, Q naught always positive. So positive and positive will be directed this way. So my electric field E, my electric field will be sigma over epsilon, because it's a conducting sheet, and it will be that. And of course, sigma will be simply Q over A, And if I have for the last part C, F is equal to QE, and Q is given, capital Q. Now this is capital Q because he said the charge is capital Q, the last charge is capital Q. So this will be, sorry, Q, and this will be capital Q, so it will be Q multiplied by E, and E is this guy over here, and that's your problem solved. Good luck, and I wish you the best, inshallah, and we'll talk more about this next. If anybody has any questions, then we can talk about this more when we do that again. Okay, yes, keep animations. And then I need to